Alright, exercise 10.5, tangents. Tangents of a circle. So that's where the line will touch the part of a circle. Where it touches is called a point of tangency, and then common tangent is where you've got two circles and the same line touches both of them. That's common tangent. Okay, so let's have a look at the new vocabulary in its entirety. So your tangent, so it tells you that line AB is a tangent, so the red line AB is your tangent, and where it touches your circle, which is point A here, is your point of tangency. And the one thing it doesn't show you by the diagram is the fact that if I draw a line to AC, which is the radius, then the tangent would make a right angle. Okay. Okay, so now let's have a look at common tangents. As you can see from the two diagrams here and in example 1, a common tangent is where it will touch two circles. And as you can see, there are three different diagrams, but all three of them have got common tangents. In this diagram here, L touches both of them. You will get them like this section here, where it actually touches both of them at the same point, or in fact it can roll over the circle and touch both of them that way. Okay, if you've got two circles, something like concentric circles, there's no common tangent at all with concentric circles. So here's question number 1, which is just a bit like the example I gave you. There is nowhere on here wherever I can draw it that I can make a common tangent, so it says write no common tangent, so that's the answer to question number 1. Okay, so now we're looking at the example here, and it's a biconditional statement. If and only if it's a tangent, if and only if it's right angles. In other words, it's a right angle to whatever the radius is. So there's the proof of what a tangent is as far as the notation is concerned. So here's a common type of question. Identify whether it is a tangent. As you can see, you've got Pythagoras here, a squared plus b squared, and this is the hypotenuse. Now don't forget, this part is 9, but this part is actually a radius, and that's where the other 8 comes from. So the total here is 17, and 8 squared plus 15 squared equals 17 squared. Well, as it says in the example, it's true, so therefore it is a tangent. Let's have a look at number 2. Pythagoras says that it's 6 squared plus 10 squared equals 12 squared, because 12 is the hypotenuse, because don't forget, if it's a tangent, your right angle is here. So 36 plus 100, does that equal 144? Well, the answer is purely and simply no, so the answer to this is no. Okay, what about this guy here? Well, again, don't forget that the radius, which is EG, is 15, so this must also be 15. So be careful. Okay, so now we've got 15 squared plus 36 squared plus 39 squared. Okay, there's Pythagoras. Yes, you can do it on your calculator. But if you think about Pythagorean triples, if you factor by a factor of 3, then you've got 5 plus 12 equals 13. So in other words, this is a 5, 12, 13 triangle, and you know by now that that's a Pythagorean triple. So the answer is yes. So sometimes you have to do Pythagoras. Sometimes, if you can simplify it, you can find your Pythagorean triples. It's entirely up to you, one way or the other. Okay, so here's example 3. And again, Pythagoras, so it's going to be x squared this time, which is the radius. 12 squared is the longer side, and x plus 8 squared is going to be your hypotenuse. Okay, so this is a FOIL situation, or square it, double it, square it will give you your quadratic. But you don't worry about it being a quadratic, because you've got an x squared on either side of the parentheses, so they will cancel out, and you're left with 16x plus 64 equals 144. Subtract 64 and divide through by 16 will give you 5. Simple. Here's the last example, and what do we know? Well, Imagine that you're standing there looking at the moon. Let's just say circle D is the moon. Then you can see actually the top of the moon and the bottom of the moon, but you are still the same distance. So these two guys must be congruent. So either it will give it you in the statement or by notation on your diagram. Okay, so you know by the statement that they are tangent, so they must equal each other. So set them equal to each other. Basic algebra takes over. Quickest way of checking if your algebra is correct is plug it back into AB and BC. So you've got 20 plus 15, and does that equal 40 minus 5? Well, both of them are 35, so the answer is yes. And it's a good quick check on your algebra to make sure you've done it correctly. All right, so we've just done the example, so now let's have a look at the questions. And it tells you that they are tangent, so if they are, you've got right angles at N and B. You haven't got one at 6, but let's have a look at number 4. That's just Pythagoras, so that's going to be 12 squared plus 16 squared, and that equals x squared. I'll let you do that one. But let's have a look at number 5. Number 5 is going to be x squared plus the 30 squared, and that's going to equal 18 plus x, and squaring that, because don't forget this part AD is x and DC is 18. So we're going to finish up with x squared plus 900. Okay, and foiling this out, you're going to finish up with x squared plus 36x plus, and the square of 18 is 324. Okay, it looks like nasty, but it isn't. That's 900. They will cancel out. Subtract your 324 from your 900, and you get 576, and that equals 36x. Divide by 36, and x will be 13. Job done. Okay, and in question number 6, they just equal each other. So 5x minus 8 equals 3x. Subtract 3x from both sides, so 2x minus 8 equals 0. 2x will equal 8. X will equal 4. Simple.